हेलो फ्रेंड्स, क्लास 12th फिजिक्स में हम लोग इलेक्ट्रिक चार्जेज एंड इलेक्ट्रिक फील्ड के बारे में देख रहे थे। पिछले वीडियो लिंक में हम लोग कूलम्ब्स लॉ के बारे में देखा था। इस सेक्शन में हम लोग देखेंगे कूलम्ब्स लॉ इन वेक्टर फॉर्म। कूलम्ब्स लॉ इन वेक्टर फॉर्म। Consider two positive point charges. Consider two point positive charges Q1 and Q2 placed in vacuum. Q1 and Q2 placed in vacuum at a distance r from each other. At a distance r from each other, they repel each other. They repel each other. Here, charge Q1 and Q2, distance between them is R. Here, force is exerting F12 and here force is exerting F21. Repulsive combination forces for repulsive combination forces for Q1 into Q2 is greater than 0. In vector form, Coulomb's law may be expressed as Coulomb's law may be expressed as F21 equal force on charge Q2 due to 1. Force on charge Q2 due to 1, and it becomes 1 upon 4 pi epsilon naught Q1 into Q2 upon R square into R21 cap, where R21 cap is the R21 vector upon mod R. R21 R12 equal vector R12 upon R12 का mod, where R12 cap where R12 cap is a unit vector, in the direction from Q1 to Q2, in the direction from Q1 to Q2. Similarly, F12 equal 1 upon 4 pi epsilon naught Q1 Q2 upon R square into R21 का cap, where R21 cap equal vector R21 upon mod R, and R21 is a, and R21 cap is a vector in the direction from Q2 to Q1, is a vector from direction from Q2 to Q1. The Coulomb's forces between unlike charges, the Coulomb's forces between unlike charges, where Q1 into Q2 is less than 0, are attractive. Importance of vector form. Importance of vector form. The vector form of Coulomb's law gives the vector form of Coulomb's law gives the following additional information. Number 1, R21 vector equal minus R12 vector. This means that the two charges exert. This means that the two charges exert equal and opposite forces. Forces on each other. So Coulomb's forces obey the third law of motion. Or law of action and reaction. as the Coulomb forces acts along. Number second, as the Coulomb's forces acts along F12 or F21, F12 or F21, that is along the line joining the, that is along the line joining the centers of the two charges, the centers of the two charges, so they are central forces, so they are central forces. Range of Coulombian forces. Our next heading is range of Colombian forces. Colombian forces act over as Colombian forces acts over a enormous range of separation R. Enormous range of separation of R from nuclear dimension to nuclear dimensions to microscopic distances as large as microscopic distances as large as 10 to the power 18 meter. Inverse square is valid over range of inverse square is valid over range of separation to a high degree of accuracy. Separation to a high degree of accuracy. Limitations of Coulomb's law. Limitations of Coulomb's law. ये जो Coulomb लॉ की जो रेंज होती है वो छोटी साइज परमाणु के न्यूक्लियस की साइज से लेकर के और बहुत बड़ी दूरी जैसे कि 10 to the power 18 मीटर तक होती है। अब हम देखेंगे Coulomb's लॉ की सीमाएं। Coulomb's law is not applicable in all situations. Coulomb's law is not applicable in all the situations. It is valid under the following condition. It is valid under the following कंडीशन। Coulomb's law केवल कुछ ही कंडीशंस में क्या करता है फॉलो करता है। द इलेक्ट्रिक चार्जेज मस्ट बी एट रेस्ट। द इलेक्ट्रिक चार्जेज मस्ट बी एट रेस्ट। यानी कूलम्ब्स लॉ स्टेशनरी पॉइंट चार्ज्ड बॉडी के लिए काम करता है। द इलेक्ट्रिक चार्ज मस्ट बी पॉइंट चार्जेज, द इलेक्ट्रिक चार्ज must be a point charge. The extension of charges must be much smaller, that is, the extension of charges must be much smaller as compared to the distance between the 2 point charges. The separation between the charges must be greater than the separation of charges must be greater than the nuclear size, यानी 10 to the power minus 15 meter, because for distances less than 10 to the power minus 15 meter, because the distances less than 10 to the power minus 15 meter, the strong nuclear forces dominates over the strong nuclear forces dominates over the electrostatic force, Now we will see dielectric constant and relative permittivity. Dielectric constant. Dielectric constant or relative permittivity. When two charges are placed in any medium, when two charges are placed in any medium other than air, or vacuum, the force between them is greatly affected. The force between them is greatly affected. Permittivity is a property of the medium. Permittivity is the property of medium which determines the electric force, which determines the electric force between two charges situated in that medium. Between two charges situated in that medium. For example, the force between two charges located some distance them when they are separated by same distance in air. This is because the absolute permittivity of water. क्या करें? The force between two charges. The force between two charges located some distance apart. Located some distance apart in water is about 1/80 of the force between them when they are placed in vacuum or in air. This is because the absolute permittivity of water. This is because the absolute permittivity of water. Permittivity of water is about 80 times greater. Is about 80 times greater than the absolute permittivity of the absolute permittivity of the air or free space. Air or free space. Our next heading is dielectric constant or relative permittivity. Dielectric constant, dielectric constant or relative permittivity. Relative permittivity. According to Coulomb's law, the force between 2 point charges Q1 and Q2 the force between 2 point charges Q1 and Q2 placed in vacuum at a distance r from each other. At a distance r from each other, it becomes F vacuum 1/4 pi epsilon naught Q1 Q2 upon r square. When the same two charges are placed at same distance in any medium other than vacuum, in any medium other than vacuum, the force between them becomes, the force between them becomes F media 1 upon 4 pi epsilon Q1 Q2 upon R square. The quantity epsilon is called, the quantity epsilon is called relative permittivity. Dividing equation 1 by 2, this is equation number 1 and this is equation number 2. Dividing equation 1 by 2, we get F vacuum upon F medium. It becomes 1 upon 4 pi epsilon naught Q1 Q2 upon R square and 1 upon 4 pi epsilon Q1 Q2 upon R square. It becomes F vacuum upon F medium 4 pi epsilon upon 4 pi epsilon naught. It means F vac upon Fm epsilon upon epsilon naught, where the ratio of epsilon to epsilon naught the ratio of epsilon to epsilon naught the ratio of epsilon upon epsilon naught is the permittivity of the medium, is the permittivity of the medium to permittivity of the free space is called relative permittivity and also represented as epsilon r or k. Then k equal epsilon upon epsilon naught and it becomes epsilon equal k into epsilon naught or epsilon equal epsilon r into epsilon naught. Comparison of electrostatic and gravitational forces. So friends, we will see this topic in my next video link and wait for my next videos. थैंक्स।